Okay. We have a test on Thursday, do we not?
Yes.
Yes, sir.
Okay. We have a test on Thursday on what?
Everything, oxidation, and
Everything.
oxidation, and ionic,
Solubility.
Molarity, solubility,
polarity.
Hess's law.
You want the objectives? I can give them to you.
Yeah, but
Delta
send them.
formation.
I don't know if you sent them before or not, but I've been busy like the devil.
I did send them.
So,
But I have them here.
haven't got
Right
it.
on the board.
no, I can't spend that time. So, okay, we talked about what the topics were last class, didn't we?
So,
I don't want you to misunderstand this. You gotta know it all, okay? If you know it all, you still might not be able to get an A. So, but if you don't know it all, what grade are you gonna get for sure?
Well, let's see.
Right? But I am known to be the easiest professor in the college.
Don't say that.
And I give everybody A's, okay? So whether you know or not, it will be okay. You will see.
Did you record it?
Yeah.
Yeah. You will see what grade I'm gonna give you. I'm gonna give you the grade you deserve, okay? All right. We were talking about what last class?
The orbitals, I guess, and
off-ball diagram.
how they shape, I guess. How they
Okay.
shape.
Yes.
You left off
Oh yeah, you left off on P shape.
Yeah, on an H, right? Like an H shape.
Yeah,
Eight.
infinity sign.
Yeah, like infinity sign.
American smart.
Aufbau diagram. Somebody close that door, please. Okay, make sure that this is coming out, okay?
Yeah, that's what I'm doing.
All right. So Aufbau diagram. The Aufbau diagram is an easy way of doing electron configuration. Okay? It's somehow a mnemonic, something you need to remember. So the Aufbau diagram, let's practice how to build an Aufbau diagram. This is called a shell, and there are shells, subshells, what else? Orbitals and spin. Those are the 4 quantum numbers that describe an electron. Okay? Now the shell are numbers. Okay? So shell number 1, shell number 2, shell number blah blah blah. Every shell belongs to what from the periodic table? No, not a group. To a period. It means a horizontal or vertical. Yeah, we need to know what horizontal means, okay? Yeah, like this, okay? So, what period is this? Period 1. This is the shell. And the subshell on period 1 is called 1s. On the second shell, how many subshells does it have inside? 2. And that is the 2s and the 2p. The third shell, the one for period 3, has what in it? The 3s, the 3p, and the 3d. Question on the test would be, how many subshells are there on the third shell? How many subshells? 3 subshells. Okay? On period 4, how many? 4s, the 4p, the 4d, and the 4f. Do not tell me this is difficult. This is not difficult. If this is difficult for you, you should not be coming to school. You should be selling. The 5s, the 5p, the 5d, the 5f, and guess what happens? We ran out of electrons in this periodic table. What that means, there is no need for a 5. What letter would you give it?
I didn't
E.
No,
You can give it whatever letter. None of those mean anything, right? They don't make any sense. On the 6th one, you have the 6s, the 6p, and the 6d. We do not write a 6f because they run out of electrons here. So they're going to decrease. And the 7th, which is the last period, will have the 7s and 7p. Outstanding. This is a way of doing what? Electron configuration. This is a way of knowing energy of these. Of course, does energy increase going down here, or is it decreasing? Is energy increasing or decreasing as you increase in these numbers? What?
Increasing.
It's increasing. I said this last class. The further the electron is from the nucleus, the what? The higher the energy. Yes? Yes or no? So the higher this number, the higher the energy. Okay? All right, so watch this, okay? I am going to start drawing lines diagonally. Do you know what a diagonal is? There you go.
Christmas tree.
And another diagonal line. Another one. How do you like that? Does that look confusing to you? A little bit. Okay? Diagonal lines. Of course, if you do it wrong, you'll notice that it doesn't make a lot of sense, yes? So this one has 3, whatever. I'm going to ask you on the test, or you have to know for the rest of your life. Draw, or not draw. Let's say provide the electron configuration. By the way, guys, do you have any questions for the test on Thursday? So I forgot to ask you, how rude of me, huh? Any questions for the test on Thursday? No questions?
Could we do a half reaction? That was weird. But I don't know if anybody else. You
Yeah,
did
but
like one of them.
If I have a
Yeah, but that's not a
problem,
big deal.
No.
if I have a problem written down that I was trying to do and I couldn't figure it out, can
You can show me it. Let's do the electron configuration first, okay? And then while you're doing that, find the problem. So, provide the electron configuration for oxygen. And in order to find the electron configuration of any element, we need to know, and of course, let's say I do not give you a periodic table. There is a way to do electron configuration from the periodic table, and this is the other way, using the Aufbau diagram. Now, some of you know how to do an electron configuration from the periodic table. But if I don't give you a periodic table, how do you build this then? Hello? Aufbau diagram, that's right. This is why I'm teaching you this way, and I am also going to teach you the other way of the periodic table. So for oxygen, we need to know how many electrons are there. How many electrons does oxygen have? 8? How do you guys know? You memorize that sort of stuff? Periodic table, you got one? What's the number on the periodic table for oxygen? 8? You sure?
Yep.
All right. Number of electrons is 8. I have to place 8 electrons. How many orbitals does the S subshell have? 1 orbital. That means 1 line. How many orbitals does the P have?
2.
3.
Oh, 3.
And the D?
5.
No, it's never an even number, okay? It's always odd. And then here?
7.
1, 2, 3, 4, 5, 6, 7. You can fill a maximum of 2 electrons in each orbit. So what is the total number of electrons you can place in any of the S's? It doesn't matter if it's 4 or 3 or 5. You can place a maximum of 2 electrons. So 2 electrons go in there. What's the maximum number of electrons I can place here? Huh?
6.
2 here, 2 here, 2 here. That's 6 electrons. What's the maximum I can place on the D? 10 electrons. What's the maximum I can place on the F? What?
14.
14 electrons. Okay, we're not done yet, okay? There is something called the Aufbau principle. Aufbau principle. What does the Aufbau principle say? Who knows? Huh? Nobody took my 1025 course, did they?
I don't know.
You see why? I must be a bad professor. No one from my 1025 class knows this. I must be bad. Because people don't learn anything in my class.
The Aufbau principle dictates that as protons are added one by one to the nucleus to build up the elements, electrons are separated.
I was like, Google me.
Should I read that too?
I was trying to answer your question.
Oh, okay. Alright. Well, I'm going to tell you, okay? The Aufbau principle says, before you fill. No. You don't write this down. You just listen. Before you fill higher energy subshells, you have to fill completely the lower energy subshells. Is this a subshell? Yes or no?
Yes.
Before I fill this one, I gotta fill the lower energy one, which is this one. I gotta completely fill it. And if I am to fill this one, I have to completely fill this one, because this is the order in which you will fill things. So after 2p, you will fill the 3s. And after the 3s, you begin in the back of the arrow, you will fill the 3p. And after the 3p, what are you going to fill? The 3d? The 3d. The 4s. And after you're done filling this one completely, you will fill this one. Is that clear? That is called the Aufbau principle. So let's write. Aufbau principle says, before filling, and of course, I don't even know if this is a formal statement. Before filling higher energy subshells, let's say U, right? Let's say U. Of course, I shouldn't be writing U, but you need to completely fill lower energy subshells. Okay, so let's do this, okay? We're doing the electron configuration for oxygen. The first subshell I'm going to fill is the 1s. How many electrons can I put in this 1s? 2 electrons. So I am going to put this 2 as a superscript. After I am done with the 1s, I begin in the back of the arrow again, and I go towards the front. I meet which number? 2s. How many can I place here? 2. I have to add enough electrons to have the number 8. Yes? So far, how many electrons do I have?
4.
4 electrons. I need how many more? 5 more, yes?
4.
So, very nice. At least you can add. The back of this arrow, and we meet what letter? 2p. How many can I add to the 2p?
4. Oh, total? 4.
No, wait a second, Luis. How many electrons total can I put in the 2p? 6 electrons. But am I going to put 6? No. You are going to put enough to add to the total that you need, which is 8. Yeah, so it's 4 on that p. Is that p completely filled? No, that p is not completely filled. Okay, and that's okay. The one that needs to be completely filled is this one, according to whose principle? Aufbau principle. Outstanding. You guys want to try one?
Sure.
Yeah?
Yep.
Let's try chlorine. How many electrons does chlorine have, for those of you that have memorized the periodic table?
17.
17.
Yes.
You sure?
Yes.
You're kidding. All right. 17 it is then. I don't remember that, but then I don't know the periodic table. I'm not being tested on.
I would like. You know.
Okay, guys. So, what do I do first?
1s2.
1s2,
2s2.
2s2, 2p6, 3s2,
3P5.
and then 3p5. You did this in this order, and you completely filled the lower energy before you can fill the higher energy one. When you add all these numbers, it adds up to 17. Is that clear?
I got a question. The P, oh, okay, so every P has six orbitals, I mean, 3 orbitals.
Huh?
I was confused because I thought that the 3P had 5 orbitals, but it only has 3 orbitals.
Yeah. All the P's have only 3. And they all look like what, guys? Like what?
The infinity sign.
Peanut. What is it with you and the peanut?
The Dr. Jimenez taught it to me like that.
Oh, she likes peanuts then.
Dumbbells.
All right. Dumbbells, that's what I was taught when I went to kindergarten and they taught me this stuff. So how easy is this, guys?
Easy.
It's very simple, yes? No wonder I'm an easy professor. I'm going to ask you for one electron configuration on the test. Okay? There are violations to this rule, which I'm going to ask you also on the test. Violations to the rule. Do you know what a violation is?
Something wrong.
Something you can't do. Okay, why don't we do bromine, my friends? Do bromine. And that's the last regular electron configuration we are going to do. How many does bromine have?
35.
35. 35 what?
Electrons.
35 electrons or protons? Both, huh? Yeah, because the element is neutral. We're going to change things up in about a second. Look, just do the electron configuration for this, which is just regular Br. And do the electron configuration for Br minus. Don't say anything, just do it. Why are you eyeballing me? I'm watching.
I thought that you're watching it, that's why I'm watching it.
Oh, okay. Guys, tell me, solubility rules for OH minus.
NH4 plus.
Group one,
Group 1 alkaline.
barium, and sodium.
2 plus tetrahydrogen.
Thanks for chanting the answer, okay? Solubility rules you for S2 minus. Huh?
Same. And so.
You gotta know them before Thursday. Don't be hurting my feelings, I'm gonna hurt you back. Okay, so let's do this one, just neutral VR. Tell me, begins on 1s2, 2s2, 2p6, 3s2, and then 3p6, and then it says 3d,
4S and then 4S2.
3p, 4s2,
Then 3.
3D10.
3d10,
4P5.
I was like, oh, yes, everybody here.
4p5.
Yes.
Okay, how nice is that?
Beautiful, outstanding.
Outstanding. He knows it, it's outstanding. All right, if we're doing the Br minus, how many electrons does Br minus have?
Oh no, you gain 1. You gain 1. So it's 36.
But if we only write the last, like the 4s2, 3s, and 4p5 in the test, is that wrong?
If you write what?
Only last part, not the whole thing.
You would have to write the noble gas.
Well, what, you guys like the brackets?
You have to
Oh,
put
yeah,
the bracket
you
AR.
bracket
That's right.
of
That's
the
You
last
like the
noble
brackets?
bracket.
No.
No,
Like
the
the
last
bracket
bracket
AR,
I like
and
the
you continue with 4s2.
That's what they taught you in 1025, huh?
No, but that's the shortcut of the noble.
Okay, all right, well, let's change how we refer to this thing. We are going to say, provide the complete electron configuration. Now, the other one, it is called like that. The other one is called condensed electron configuration. And condensed is not complete. When I ask for the electron configuration, that is the complete electron configuration, I expect that from you. If you write, if I ask you, give me the condensed electron configuration, then you can do brackets. Okay? But I haven't shown you that yet, so we don't know. If you know that from before, may or may not be okay on the test. If I am not clear, then I guess you can do whatever you want, as long as it's correct.
Outstanding.
So far this is called complete electron configuration. Now, if a bromine has a minus charge, what has it done?
It's
Adding
gained
an electron.
It has gained an electron, so the electrons, the amount of electrons, instead of 35, now would be 36 electrons. It will be the same electron configuration,
You filled the
with the
last
only
one.
difference.
The P will be filled.
That the P will be filled, and that will have a noble gas configuration. Yes or no? The noble gas configuration of what element?
The one after it, I don't remember.
The one after it, but which one is it?
Krypton.
Krypton, I don't know what element that is. What is it? KB?
KR.
KR? Alright, so this has a noble gas configuration. All elements want to have a noble gas configuration, yes?
Yep.
That is called the octet rule. So the octet rule says, why don't you write it down? Octet rule says all elements tend to gain, lose, or share. Octet rule, all elements tend to gain, lose, or share. Electrons in order to have a complete octet or noble gas configuration. And that applies only for representative elements. That means elements in the S and in the P area, which I haven't explained yet. I'm going to explain that, I don't know when, but at some point. What did she say?
I'm studying some rules.
Well, you're studying Solidity rules now.
No.
How upsetting to see this handwriting. This handwriting is all over the place. How crazy. It looks completely. Okay. So all elements, one, yeah.
You said applies to what?
Representative elements. So right, representative elements, even though I haven't explained what a representative element is. I told you representative elements are those elements in the S area and in the P area. I haven't explained that either. But I will, so don't worry. And of course, you guys want to do the, now we'll do the condensed electron configuration when we have a periodic table, okay? Let's do something called orbital diagram. Provide the orbital diagram for, let's do oxygen again.
Is that with the spins?
Yes, this is with the spins.
No.
This is gonna be a test question too, right?
Which one is going to be a test question? The orbital diagram? Yeah. And so is the Aufbau principle and the octet rule. I'm not going to ask you to draw the Aufbau diagram, but you need it. Now the orbital diagram is it the same thing as the electron configuration? No, that's why it has a different name, yes? But it shows you what? The orbital diagram shows you the orbitals. And the orbitals, the way I have explained this to you, is with these lines on the top, is it not? So all you are going to do is the electron configuration, but instead of putting it a superscript, you're just going to draw the line and then electrons in. Okay? I'm going to show you how to draw the electrons in it. I haven't taught you that yet. This is called Pauli exclusion principle. A whole bunch of fancy names, yes? You guys imagine how much you would be liked if they're making a barbecue, everybody's drinking beer, and you start explaining Pauli exclusion principle? You'll be like the hero in the party. All the girls would jump to you. Say, damn, you're the man.
Well, if they're
All right.
taking chemistry.
Nah, you explain it to them, they're gonna love it. Pauli exclusion principle says no two electrons can have all four quantum numbers. And of course, all four quantum numbers, the way I have diluted this for you, right? I have diluted it. I haven't been using the right words, right? I have used words like shell, subshell, orbitals, and spin. They have fancy words for those, okay? Which we're gonna do next, okay? Don't worry. You'll know all the fancy stuff for that party you wanna attend. What does this translate into? You can't have all four quantum numbers, right? And all four quantum numbers means shell, subshell, orbital, and spin. Basically, this translates into electrons within the same orbital. Electrons within the same orbital must have different what? Different spins. How many electrons can you place in one orbital? Two electrons, okay? So those two electrons that you place in that one orbital, one has to be spinning one way while the other one is spinning the other way. Now it doesn't matter what way they are spinning, but if you are drawing it like this, an electron is an arrow with a half of the head. That's called a half-headed arrow. Got it?
You can't just put a regular arrow?
No, I cannot put a regular arrow because a regular arrow is reserved for two electrons, at least in organic chemistry, and one electron is like that. Okay? Now, most professors or most people don't care. The book might even do it with two heads. I don't like the two heads, okay? So, you do it one head, get used to it. Now, if your professor from the lab tells you, hey, it's two heads, then don't fight with the guy, okay? It's okay. They can do it with two heads, it's fine. But this is the way I want it, because one-headed arrow means one electron. The other one has to be spinning the other way, and the spinning the other way is like that. So one is spinning clockwise while the other one is spinning counterclockwise. Is it called counterclockwise or counterclock? Counterclock by itself? That's so weird. I never understood.
Professor,
Yeah.
the arrows, does it have to be first pointing up and then pointing down? Or
Yeah.
First point
as long as it's half?
No, you can put it whatever way you want it. It doesn't matter how you put it, as long as the other one is the total opposite of it. I mean, you could do this like this, right? This one I'm pointing towards the inside, right? And this one like that. Of course, you're trying to be a pain, right?
But what is
This looks cuter, yes?
But what if the subshell is not completely filled? Of course, you have to fill the going up first and then going down.
Like I said, it doesn't matter how you put it, because the going up or the going down, it doesn't make a difference, as long as it's one spin. Now, this arrows it's made up by us, yes? It doesn't matter how you put it. If it's only one, you can put it like this. It doesn't matter. Of course, I don't want you to do it like this because I have been drawing it like this. That's the first one I draw, so you could start doing it like that, but if not, it's okay. So let's do the...
Yeah.
What? Go ahead.
The arrows mean spin.
The arrows mean spin.
Okay.
Well, no. The arrows mean an electron. One way is spinning the electron and the other is spinning the other way. So, if we're drawing the orbital diagram for oxygen, we need another of these interesting rules, and that's called Hund's rule.
Yep.
Guys, I forgot. Is Hund's rule with a D or with a T?
Probably a T.
You sure? The tomato paste with a D or with a T?
No, tomatoes with a T, right?
The tomato paste is with a T?
Yeah, Hunt, yeah.
Nobody be cooking in here, huh? Hund's rule. Yeah, the tomato paste is with a T. And this one happens to be with a D, but this is not a spelling bee, yes? So if you write a T here because you're confused with the tomato paste, it's okay with me, right? Now, Hund's rule is with the D. And Hund's rule says, I don't know how to explain. That one's a tough one, yes? Hund's rule says, in a multi-orbital subshell, you are going to place, no, you listen before you write. In a multi-orbital subshell, which one am I talking about from the get-go? Am I talking about the S?
No, the P.
It's not the S. The S is not included.
Yeah.
In a multi-orbital subshell, that means it could be the P, the D, and the F. In a multi-orbital subshell, before you pair the electrons in the same orbit. Got it? Before you put the electrons together in the same orbital like this, you are going to put them in different orbitals with the same spin. Yes? Look at this picture. If you have a multi-orbital subshell, before you can do this, before you pair them, you are going to put them in different orbitals with the same spin. What do you like better, a picture for that or words?
Words.
Picture?
Picture. Yeah. Picture.
Just say, you don't have to write it. The multi-what?
What, do you think I'm lazy and I don't want to write it?
No, it's fine.
No, I will write it. Why are you saying that I'm lazy? This is staying forever marked in there. You're going down the stairs today, you're gonna trip over. All right, Hund's rule says,
Don't take the stairs.
if you take the elevator, your head gonna get stuck in there. Okay, before pairing electrons in a, and this is different from what I said before, right?
Yeah.
Yeah, wait.
Multi-orbital subshell. Before pairing electrons in a multi-orbital subshell, place the electrons in different orbitals of the same subshell, yes? In different orbitals with the same spin. I'm exhausted. You guys tired? Huh? 'Cause I would not be able to guess what you're tired of. You're sitting down. So let's say oxygen. How many electrons on oxygen?
8.
8 electrons. Standard. And the first one is the 1s. Yes or no?
Correct?
I am going to draw this orbital on top of that, and I'm going to draw electrons in. Is this okay?
No.
No.
That is not okay. It is a violation to whose rule?
Poly.
It is a violation to Pauli exclusion principle. Okay, you have to know this. I'm going to give you violations on the test, and you tell me what they are violations to. So this is a violation to Pauli exclusion. Well, it was, not anymore. And now comes the 2s. Electron, electron. Outstanding. And then comes
2P.
the 2p. And the 2p, first of all, how many electrons do I have so far? 4. I need another 4. Here's the first one. Now the second one is going to go where?
The second
On the second orbital, because of Hund's rule. Hund's rule says before I can pair them, I must place them in different orbitals. Now, is this the same thing as this?
No.
What is different about this?
You skipped an orbital.
You skipped it.
Okay, write this down. The orbitals within the same subshells, are degenerate. Degenerate. Degenerate, and of course, why don't you ask what does degenerate mean, right?
Letting it out.
What?
Letting it out.
Yeah, I've been called that before. So, it means the same energy. Degenerate means same energy. For those of you that are getting a major in English. Degenerate means same energy. So is there a difference in energy between this P subshell and this P subshell? No. Is there a difference in energy between this one and this one? No. Is there a difference in energy between this one and this one? No. Because they all have the same energy, the electron can go in either one of them without a problem. Okay? Of course, it's not pretty you do this, yes? Is it pretty?
No.
No. Girls will understand that very well. This is not pretty, so we are going to do it like this. But it's okay if I write it here. Is this okay?
Yes.
That is okay. Because they have the same direction, they have the same spin, and they are in different orbitals. Since all the orbitals have the same energy, it doesn't matter if they're the last two, in the first two, or in the ones in the corner. Yes? If you do this on the test, you are trying to be a pain. That is still okay. So this is what we do. By convention, just because this is the way we do things most of the time, that's the first one, and the second one will go here. And then I need 4 of them. There it is. Now this is half filled. Is it not half filled? It has 6. It's supposed to have a maximum of 6, and it has 3. And now I do this. Now is when I can pair them. Now, can I pair them on the 3rd orbital?
Yes.
Yes. Can I pair them on the 2nd orbital?
Yes.
All right. Good. Which one do you want to do now? Which one is the next one? Let's do nitrogen. Do the orbital diagram for nitrogen.
This one. I was trying to do it. And this is my work right here.
Are you still able to see? Yeah. I think I'm gonna have to push it back next time. I don't know if we can actually see in detail what's written. Yeah.
It's pretty good.
And then I looked at the answer and I got a confusion.
You sure we didn't lose it?
It might have been.
Does this matter if you start with the spin downwards? That doesn't matter.
Doesn't matter. You know your conversation is going to be there, right? Huh? Okay, what is it?
7.
1s. Oh, how many electrons?
7.
7 electrons. That's good?
No.
Tell me, what violations does that have?
That's the Hund rule.
Supposed to fill
Two of them.
The Hund rule.
Two,
No,
one.
policies.
No. Tell me what they are.
It doesn't have enough electrons, that's Aufbau principle.
You're supposed to fill all the.
What principle?
All the 2s.
Okay,
All the
Aufbau principle is the first violation.
Right.
Before you can put electrons in the 2p, the 2s has to be filled, yes?
Correct.
It's a violation to that rule. What else? It's a violation to Hund's rule. Before I can put them paired in a multi-orbital, I must place them in different orbitals with the same spin. Okay. Is this okay?
No.
This is not okay. What is that a violation of?
All the exclusion principle.
Poly? Is it poly?
Yes.
Oh, it is poly.
Where's poly at?
Right here.
Not poly.
The 2S. The 2S.
That's not poly.
It's Aufbau. I have no idea.
The 2S?
It's still fine.
Poly is like
The 2S?
same spin in the same orbital. That's poly. Same spin in the same orbital. This is, it's still Hund's.
Hans.
That's Hund's rule and the Aufbau principle. I'm gonna ask you 3-4 questions like that on the test. I'm gonna give you orbital diagrams and ask you what are they a violation of, okay? Yeah.
Fine. So the 2S is not considered poly extension?
Poly exclusion principle?
Yeah, I'm sorry.
No. For it to be Pauli exclusion principle, it has to be 2 electrons in the same orbital with the same spin.
But don't you have to fill up the orbital before you go to 2B?
Yeah, and that's called the Aufbau principle. It's not Pauli, it's Aufbau.
Can you show an example of a poly?
Yeah, man, that's what I'm doing
Oh,
right
okay,
now.
okay, gracias, thank you.
The P doesn't have to have the same spin, the one before, unless you didn't correct.
One S.
You just correct.
Is the violation.
Let's say that. What are those violations of?
Poly or one S?
Which one is Pauli?
One S.
This is Pauli, because in the same orbital, you have it with the same spin. It can't be like this. It has to hit different spin. This is another violation. What is this a violation of? Hund's rule. Because if they are in a multi-orbital subshell, they had to have different orbitals. Electrons on different orbitals with the same spin. Yes or no?
Yes.
Those are gonna be 2 or 3 easy questions on the test, right?
Yep.
What was the nitrogen violation of Hans rule again?
What? No, I didn't say nitrogen is a violation of Hund's rule.
Oh.
What I wrote incorrectly is a violation, right? I did this incorrect. Nitrogen is not a violation. So we're still doing nitrogen, okay? I just jumped into something that was wrong. For you guys to learn from my mistakes, yes? So how many electrons? 7. 1, 2, 3, and now I have to place the next one here. If not, I will be violating Aufbau principle. And then I need, how many more?
3 more.
1, 2, and 3. Okay? Of course, that is not a violation to the rule because those elements in the P area and in the S area do not violate the octet rule. The ones that violate some of these rules are, well, some of them, not all. It's elements in the transition metal area. The elements. Okay? Guys, what time is this class over today? In 10 minutes?
15.
Okay, somebody wanted to do a Hess's law problem. This Hess's law has becoming a thorn in my neck.
I hate it.
I don't know how many Hess's law problems I have done. Why are you guys stressing?
I don't fill up in Hess anymore, just take it.
Okay, this is what